discuss all about the problems on functions. So you see the problems one by one, how these problems can be solved. Problem number 1. See that what is the question here? Let f of x is equal to x square and g of x is equal to 2x plus 1 be two real functions. So here you have to understand the questions asked here. Find number 1. You can see that f plus g of x. Number 2, f minus g of x. Number 3, f g of x. Number 4, f by g of x. So these are the functions to be calculated, and here we have to understand how to find out these results. In the last class we discussed about operations on functions. So using those operations we can go for solving this f plus g of x. So f plus g of x, look this, f plus g of x, formula says f of x plus g of x. What is f of x? X square. What is g of x? 2x plus 1. Yes, this is the answer. Similarly, second one, f minus g of x is equal to, formula is f of x minus g of x. What is f of x? X square minus 2x plus 1. When you open the bracket, minus 2x minus 1. Similarly, you can go for third, f g of x is equal to f of x into g of x. The formula is x square into bracket 2x plus 1. This is finished. And the last, number 4, f by g of x is equal to f of x divided by g of x, and f of x is nothing but x square divided by 2x plus 1. This is the solution. And here you have understood that how you got this answer, and try to understand this should be not 0. It means 2x plus 1 is not equal to 0. It means that 2x is equal to minus 1 is not equal to minus 1. X is not equal to minus 1 upon 2. See, x is not equal to minus 1 upon 2. So here you have understood how to find out the functions. Addition of functions, difference of functions, product of functions, quotient of functions. So this is the way how we find out these results. Next, we'll see that another problem, because only the problems on functions we are discussing here. And one thing you observe that as per the PUC circular, this academic year 30% of this total syllabus is reduced. That reduced syllabus already I have sent to you, just to go through the things, the portion retained, portion deleted. But so far we have done everything, but now you have to follow the portions for this academic year, and that already I have sent through your WhatsApp. So follow the things, what are the topic, what are the subtopics to be covered. Next, second problem, you see that second problem, look this, let f of x is equal to root x and g of x is equal to x be two functions, be two functions defined over the set of non-negative real numbers. Non-negative real numbers. Question is, find number 1 f plus g of x, number 2 f minus g of x, number 3 f g of x, number 4 f by g of x. So try to understand. F of x is root x, g of x is only x. Be two functions defined over the set of non-negative. Non-negative means positive and 0, non-excluding the negative numbers, and what includes positive and 0. See the solution, how you can find the results here. First one, you see f plus g of x is equal to, the formula says f of x plus g of x. What is f of x? Root x plus g of x is, yes, finish. Second one is f of g of x is nothing but f of x minus g of x, that is root x minus x. Number 3, f g of x is equal to f of x into g of x. This is root x into x. So this is x raised to 1 upon 2 into x raised to 1. So x raised to LCM is 2, 3 by 2 you can say. So similarly you can simplify. The third one is, what is the fourth one? What is the fourth one here? F of, look this, f by g of x is equal to, formula says f of x divided by g of x, that is nothing but root of x by x. F of x is root x, g of x is x. So here you can understand that you will see the result. So simplified form may be written, but here try to understand that denominators never be 0. Or you can see x raised to 1 upon 2 into x raised to 1, x raised to 1 upon 2 minus 1, x raised to 2 minus 1 upon 2 you can say. This is also the part can be simplified way. This is the way of finding the sum, difference and products as well as quotient of two functions. Now let us see that other type of problems that I am going to discuss here. So the next problem I am going to see, this third one, you see, find the domain. Look this, find the domain and the range of the function, and range of the function. Find the domain and range of the function. So function is given here. What is function given here? F of x is equal to root of 9 minus x square. So here you have to find out both domain and range. Domain means the values of x, range means the values of f of x. So here you see that this problem you have to go for finding the values of x, and what are the possibilities of there to take the values of x, and the values of x is taken as, that is the elements of the domain you can say. So you try to understand, in general, if you go for square root of negative number, square root of negative number cannot be defined. Once again I understand, square root of negative number cannot be defined. If negative is there inside, it should be a complex number. But we are discussing about the real valued functions. That is why this should be positive. So here that it is clear that what 9 minus x square is greater, or you see less than 0 is not defined. I hope explaining here once again, clear that square root of 9 minus x square less than 0 is not defined because it is complex. So 9 minus x square should be greater than or equal to 0. It may be seen, or here you see this always not possible, and it should be there that it should be greater than or equal to 0. Once again I say that we are finding the values of x, the values of f of x for the domain and range. So now we have understood that 9 minus x square is greater than or equal to 0, then only it is defined. Look this, what comes here, 9 minus, see here, 9 is greater than, or you have to go for taking plus x square add, then you have to write x square. 9 is greater than or equal to x square. What I have done, inequalities, both are x square should be added. It cancels that, so that 9 is greater than or equal to x square. So that it is nothing but this inequality, x square is less than or equal to 9. It is nothing but 9 is greater than or equal to, see that. From here to here you will try to understand. How you have got that step? Adding both sides x square. So x square is, what you say, less than or, and when you go for x, this x is lesser than, and you have to go for the value plus or square root plus or minus 3, and you try to understand x is greater than or equal to 3, or x is, and here you have to go for the value in between plus 3 and minus 3. In between plus 3 and minus 3, x is greater than or equal to minus 3 and lesser than or equal to 3. So that this is in between minus 3 and 3. X is lesser than or equal to 3, and here you will see which is greater. X, this is square root of 9 is plus or minus root 3. That is why I am explaining that plus 3 and minus 3 will find this. And you try to understand that x is particularly the two possibilities are x is once 3 and once minus 3. So here we will see this, and try to understand when you go for x is less than or equal to 3 and it is greater, lesser, so x is lesser than or equal to 3 and x is greater than or equal to minus, so that it comes in between plus 3 and minus 3. Look here, x, if you take the positive, x is lesser than or equal to 3, but x is greater than or equal to minus 3. You have to understand that how you see that x is greater than or equal to minus 3. So what do you mean here that x is and greater than or equal to 3, here less than or equal to, you see this is x is, you have to write that x value is lesser, you can see this, and here you have to say greater than minus 3. So the values of x is lesser than or equal to, that is, here when you go for writing the values here, lesser or greater, and you try to understand how x is in between plus 3 and minus 3. X is lesser than or equal to 3, x is greater than or equal to minus 3. It is in between 3 and minus 3. So x should be greater than or equal to minus 3 and lesser than or equal to 3. X should be here greater than or equal to minus 3 and x should be lesser than, so this is the case. So the values of x is plus 3 and minus 3, and domain you can say easily that this implies x belongs to minus 3 and plus 3. So closure, see, lesser equal to, therefore domain of this function, domain is equal to minus 3 and 3. The domain is also the set, that we can see, domain of what? The domain of the function f minus 3. So here you make it a clear understanding that the value of x is lies between plus 3 and minus 3. X is lesser than or equal to 3, x is greater than or equal to 3, so we can write, so this is the domain. Now I am explaining that how to find out the range. Range means values of x. What do you say? Range means values of x, values of f of x. So here you try to understand that f of x is given here. What is f of x? Square root of 9 minus x. So suppose if you take x is equal to minus 3 and x is equal to plus 3, what happens? Suppose if you take x is equal to 3, x is equal to 3, what happens here? 0 you will find, because 3 square is 0, and x equal to that time also 0, and minus 3 both is 0. Suppose x is equal to 0, if you take x is equal to 0, you will get 3. So this is defined when x is equal to 0 and x is equal to 3. And try to understand that it should be defined. It is defined. It is defined, or we find the values that it is defined that x is equal to 0 and x is equal to 3. So now you have to go for writing the result, that you have to see that particularly that range. When you are writing that, it should be what? Plus 3, 0 and 3. So that you can tell that range of the function is 0, 3 you can write. So when you write 0, 3 and try to understand both may be equal, and this is the range. So it should be defined that x is equal to 0 or x equal to 0, 3, x equal to 3, 0. So it is in between that, and in between these 0 and 3 it should be defined. For example, 2 you take, you will get positive. If you get 1, you will get it positive. So you have to see that this f of x is defined in between 0 and 3, and you see that value is 0. X is equal to 0 is possible, x is equal to 3 is possible, x is equal to in between 0 and 3 is also possible, and that is why you have to see that x belongs to when x is minus 3 and plus 3, and we will get 0 and 0. So you have to see that this function is defined only for this, and range is 0, 3 you can say. And once again you can understand that how to write the range. Range means values of x. Values of x means, and see that one in other way, x belongs to minus 3 and plus 3, and f of x you have to see that belongs to 0, 3, and try to understand, you have to go for square, it is equal to 0 and equals. This is the way how you can write the result. So when x belongs to this case, you can go for writing the result. So in other words also I am explaining this. Don't get confusion that how you have to take it this. For example, once again I tell that f of x is equal to 9 minus x square. This is not defined when it is less than 0. So domain you can write here directly, that domain of this function, and only the possibly values of x, and x must be belongs to R, and try to understand that root of 9 minus x square, and this also belongs to R. So domain is root of 9 minus x square, that should be belongs to R, and you see that what are the possibilities are there, root of 9 minus x square. So that x belongs to R, when you see this x belongs to R, and try to understand root of 9 minus x square, and basically that it should be greater than or equal to 0, and when it belongs to real number, and this x minus x square is greater than or equal to 0. So try to understand when it belongs to the real number, and it should be greater than or equal to 0. So what happens is x belongs to R, so 9 minus x square is greater than or equal to 0. You have to see that, and particularly that if you go for transferring the values, you can go for x modulus of x is less than or equal to 3. Modulus of x is less than, see, to get the greater than 0, you have to say that x is equal to 3, you will get a 0, and you have to go for the other values that in between the result, it should be taken that 0 and 3. So now you see that when you go for x is modulus of less than or equal to 3, and you see the values, what are the possibilities? Minus 3 and plus 3. This is the, what do you say, domain, you can see in other way, domain of this function. And here also I tell you how to find out the range of the function. The range means the values of f of x. The range is what? Values of f of x, range of the function should be defined. So what you say, the values of x means root of 9, values of f of x is root of 9 minus x square. And see here x belongs to, that already we have discussed, 3 and plus 3. The values of x belongs to 3 and 3, for which you have to find out the values of x. And this is quite possible that minus 3 and plus 3, you will see that result when it should be, if you see this minus 3 plus 3, it will be 0, and if you take 0, so it shows that 0 and 3. So this is the range of the function. Either you go for defining like this, or the other way which I have told you. So once again, minus 3 plus 3 is the domain, and 0, 3 is the range of the function. So like this you can go for finding other values which I am going to define in other examples. So try to understand that how we explain to find out the domain and range. So here also I take some problems that how to see the proper answers. And now you see that for each value of x, we find the value of f of x. Now you see that number 4th problem, find the domain. Look this, find the domain and range of the real function, and range of the real function f of x is equal to modulus of minus of x. So here you have to explain the domain and the range of this function. See, mod x, that already that we have discussed, mod x modulus function you have studied, this is equal to 0, x is equal to 0, this is equal to minus 1, x is less than, and this is equal to 1 if x is greater than 0. This is the value of the modulus. Now here you have to see that minus modulus of x, that should be taken here. So given what, see how to find out the domain, I will tell you. F of x is equal to minus of modulus of x. So make it clear understanding that, so it should be defined for all values of x. And here you understand that f of x is defined. So now it is clear that, look this, it is clear that f of x is defined for all x belongs to R. For all x belongs to R. So what is the domain? The domain is what? Set of real numbers. Make it understanding that how you get it the real numbers, that too values of x. Whatever the values of x, you take it and it is defined. And so f of x, that is minus of modulus of x, is defined for all values of x. Now here you have to see that here also you see that clear that what, minus of modulus of x, this is the value of f of x we have to discuss, and it should be is either 0, and you have to tell particularly, you see that either 0, this is modulus of x, the possibilities you will get it 0. When modulus of x is 0, you will get 0. And here if you get it that x is equal to minus 1, and again you will get the result of minus 1, negative value we get it. So if you get positive, you will get it negative, we will get it negative, we will get it negative. So it is 0. The possibilities are there 0 and negative. So that is why I am telling that minus x is what? Either 0 possibilities, either 0, and otherwise we can say that the negative real number or negative real number. Look here, why we get the negative real number? Because modulus of x, you may say that plus 1 or minus 1, we will get it the negative of real number. So here you see that 0 and what negative means, it is a non-positive. So that range is nothing but what? Range is 0 and negative means set of all non-negative non-positive real numbers. What is the answer here? Non-positive real numbers. So the thing is that whatever you take it, either the 0 or negative, the set of non-positive real numbers you can say. And when you see this result here, the range is what? And set of all non-negative and including 0 that we are telling, so that this open bracket minus infinity to 0. Look this, minus infinity to 0, and here we write the closed bracket minus infinity. So these numbers are non-negative and 0. 0 is closed, it may be equal to 0 and may be equal to not minus. So the answer is like this, or some authors they write like this. So you write it any, and range is minus infinity to 0, that you can say. So this is the way of finding domain and range of the function. So now we go for other types of problems that we can discuss here, that whether the function is a real function or not at all a function, that we have to see in problem number 5. So in the problem 5 we can check it. What do you see that? Which of the following relations? Which of the following relations? Which of the following relations are functions? Are functions? See the question. Give reasons. Give reasons. It is if it is a function. If it is a function, determine its domain and range. So question number 1, 2 1 5 1 8 1 11 1 14 1 17 1. First problem. Second, we have to go for this set of ordered pairs because the relation. Second one is 2 1 4 2 6 3 8 4 10 5 12 6 14 7. And the last third one you see 1 3 1 5 2 5. These three functions, now relations, which are the functions? Which of the following relations, these are the relations, are functions? Give reasons. If it is not a function, if it is a function, then you have to find out the domain and range. See that whether it is a function or not. If it is a function, no two ordered pairs have the same first element. 2, this is 3 or 5, this is 5, 8, 11. So this is a function. Do you know why? Because no two ordered pairs are not having the same first element. It is a function. When it is a function, then you have to tell that domain and range. Domain means here you see, yes, it is a function. Why it is a function? You have to tell that each element of the domain is associated with a unique element. And you see that? Only one element. So what is the domain here? In the first case, so domain is equal to first elements 2, 3, 8, 11, 14, 17. And what is the range of this? Range is second element. Second element is only 1. In all cases 1, 1 is there. So it is a function. Why it is a function? No two distinct ordered pairs have the same first elements. Okay. Now next you see 2, 4, 6, 8 and 10, 12. Here also it is a function because no two distinct ordered pairs have the same first element. And then what are the domain? Yes, second is also, it is a function. It is a function. Definition you have to say, no two distinct ordered pairs have the same first element. Then it is a function. Then what is the domain? Domain means, you see, domain is first element. Domain is first element is what? 2, 4, 6, 8, 10, 12, 14. Then what is the range? Range is second element. Second element is 1, what do you say, 2, 3, 4, 5, 6, 7. See that how you tell that range of this. Next, number 3. Look this. 1, 3 and 1, 5 have the same first element, is not a function. And here you have to see 1 is also associated 3, 1 is also associated. And the element 1 is not uniquely associated, it is associated 3, it is associated with 3 and 5. The element 1 in the domain is associated 2 elements 3 and 5, so that it is not a function. So it is not a function. Why it is not a function? It is not a function. When it is not a function, there is no point to write the domain and range. Why it is not a function? Because the element 1 in the domain is not uniquely associated. It is associated with 2 elements 3 and 5 in the codomain, so that it is not a function. This is the way how we explain the relation is function or not. So similarly you can go for some other problems. We'll see now. This is problem number 5 is completed. So let us see that this next problem. Here also we see that domain range of the function, but slightly different that you can understand. So what is the second? You see number 6. A function f is defined by f of x is equal to 2x minus 5. Write down the values of number 1 f of 0, number 2 f of 17, number 3 f of minus 3. The answer is very simple. See this. What is the given here? Given what? F of x is equal to 2x minus 5. The first answer is f of 0. This means 2 into 0 minus 5. Answer is minus 5. Second one is f of 17. This is 2 into 17 minus 5. That is 34 minus 5. This is 29. And here you have to see that next you have to go for third one is what? Third one is f of minus 3. F of minus 3 is what? F of minus 3, 2 into minus 3 minus 5. So minus 6 minus 5. That comes minus 11. So this is a way of finding the functions here according to the given data. Now let us see that next problem, how to solve this problem number 7 I am going to discuss. See, problem 7 is again different, and try to understand how to find out the values here. The question is, problem 7 is somewhat interesting. The function, you see, the function t here which maps what temperature in degree Celsius into what you say temperature in degree Fahrenheit. You have to see that Fahrenheit, because here you have to see that centigrade to Fahrenheit, and you have to see this Fahrenheit is defined by f of c is equal to 9c divided by 5 plus 32. Question is now find number 1 what? Number 1 is T of 0, number 2 is T of 28, number 3 is T of minus 10, number 4 is the value of C. The value of C how to find out, where condition is given that where T of C is equal to 212. Look here once again, I am explaining. You know the temperature measurement of temperature in two systems. One is centigrade system and the other one is a Fahrenheit system. Now we are converting to centigrade to Fahrenheit. Here you see that T0, 28, minus 10, these are in centigrade. You have to convert into Fahrenheit, and that is given by the formula. So this is in centigrade and this is in Fahrenheit, and here you have to see the function t you have taken. So here you have to see that function t, and this is a formula. We have to convert degree centigrade to Fahrenheit. T of C equal to 9C by 30 plus 32 is the formula to change centigrade to Fahrenheit, and you have to use this formula. This formula why you have taken, this is a function. Earlier we used to use the function is f, here the function is c, and accordingly you can understand that how it is converted. So now I explain that how you convert. The first one you see, what is the first one? T of 0 you have to calculate, and we have the formula. What formula? T of C is equal to, you have to remember this is 9C by 5 plus 32, and this implies T of 0 is equal to 9 into 0 divided by 5 plus 32. So 0 plus 32, and this is 32. So here, and here you understand 0 degree centigrade is 32 degree Fahrenheit. So this is a way of converting to all the results here. Similarly, you can go for finding the result T of 28. Look, this second formula, second is T of 28. See, T of C formula is 9 into 28 divided by 5 plus 32. So after the simplification of this, you can go for finding 412 if you multiply divided by 5. Similarly, number 3, you see that T of minus 10. So 9 into minus 10 divided by 5 plus 32. So this is minus, this is, you go for 5 ones or 5 twos. This is minus 18 plus 32. So when you simplifying this, and accordingly you can see the result, that is 14 you will find. And number 4, you see the value of C, where T of C equal to 0. We have formula C. T of C is equal to 212. T of C is what? T of C formula 9C by 5 plus 32 is equal to 212. So the result, you can see that 9C divided by 9C divided by 5 is equal to 212 minus 32. And even you can see the result, that how you have to calculate. So now you simplify this from C, you will get it 100. We can calculate the value of this result. You will be answer C, you are getting 100. So what happens here? Converting degree centigrade to Fahrenheit using the function 9C by 5 plus 32. 9C by 5 plus 32 is the formula for converting Celsius to Fahrenheit. And at last, one more problem I am discussing, that how we see the range and domain of the function defined here. Always you remember that the function should be taken in a particular order, and accordingly you can continue the results. So the lastly, I want to see that number 8. What is that question you see? Find the range. Find the range of each of the following. Each of the following functions. Only have to calculate the range for the following functions. Number 1 is f of x is equal to 2 minus 3x, and here x belongs to R and x is greater than 0. And second one, you have to see that f of x is equal to x square plus 2. X is a real number. X is a real number. Problem number 3, f of x is equal to x. X is a real number. For all these 3 functions, we have to calculate the range. So the solution, number 1, you see this. So 2 minus 3x, x should be greater than 0. X should be greater than 0 means, you see, suppose if you say that x is equal to 1, you will get negative. X is equal to 2, you will get negative. X is greater than 0. If you take 0, you will get 2. And if you take x is greater than 0, and ultimately it should be negative. So that is why you have to go for x is greater than 0. And I explain here, according to the condition given, f of x is equal to 2 minus 3x, and for all x belongs to 0 and x is greater than 0. When x is greater than 0, you have to see that f of x is equal to, suppose x is equal to 0, you will get it 2. And you go for other x is greater than 0 means you will get it a negative value. So x is greater than 0, f of x, that is particularly here this implies 2 minus 3x is greater than 0. X is, suppose if you see that values x is 0, you will get it 0. But when you see that value of this 2 minus 3x, just to discuss once again, 2 minus, suppose x is equal to 0, we will get it 0. X is 1, will get negative. So you will get it the negative values. And that is why you have to tell that the values are always negative and 0. So that is why you have to go for the value of this domain and range. We are discussing only about the range. Range means values of f of x, that we have to discuss here. So when x is equal to 0, you will get it 2. and all are negative. Negative, how many negative? We will find this. And you see that 2 minus 3x, this implies 2 minus 3x. See, x is greater than 0, and you have to go for this is less than 2. Less than 2. Suppose equal to 0, you will get the result. When 3x minus 2 minus 3x is less than 2, and ultimately you can understand that the possible values, that range is equal to maximum is 0, and this is minus infinity to 0. This is also opened. Why? Strictly greater than 0 is there. Minus infinity to the value is when x is equal to 0, we will get it 2. So minus infinity to 0. Once again, this maxima is lesser than 2 and all negative up to negative. So you go for like this. This is x is 1, 2. You have to see lesser than, and values of f of x, you will take it any value, you will get it negative. This is a range, minus infinity to 2. Both are opened. Likewise, see the second one I am explaining here. What is the second one is f of x is equal to x square plus 2. See here, x is a real number, and you will take it any real number you take it. Suppose x is equal to x square plus 2. If x is equal to 0, what will get? 2. And if x is equal to, so you will get it any number, 0 to any number. So 0 to infinity you can take it. So that particularly when x is equal to 0, the range you will see that 2. So that our range is what? First value is 0. When x is equal to, you see that x is equal to 0, what is f of x? F of x is 2. And then next you will continue like that, and ultimately the last one is plus infinity. So is equal to 0, you get it, and any value you can see that is open. Infinity is never be taken as close to infinity. This is second. Similarly, f of x is equal to x, and whatever the values of x belongs to R if you take, and any real number, f of x is also real number. So the range is equal to set of real numbers. So this is the way how we find the range of the given functions. So I give some more examples for you to work at home, and that can be followed by you. So next class I want to discuss about part E, part B, part C, part D. That is the last class of these relations and functions. So today I am sending all these, and you make it practice, and last class we will see tomorrow. Thank you.